Welcome everybody to another BIM broadcast. My name is Shawn. I'm the technical evangelist for a company in town here, CTC Software. I'll be talking a little bit about some of their software today, but about a bunch of other software as well. Today's discussion, we're going to be talking primarily about big data. And I'm keeping an eye over there on that chat window, so if you've got any comments you want to share back with me, you want to interact, dialogue, that would be fantastic. I'm running this show solo today because I want to just bring you some information that I kind of was on my mind after having a lot of discussions with people this last couple of weeks following the BILT conference that we were just at down in St. Louis, Missouri a few weeks back. So I went to the pre-conference for BILT. It's called Data Day. And at that particular portion of the conference is one day that's dedicated to nothing but just talking about data acquisition, data analytics, just data. It's all about the information behind your Revit models or your building information models. And it was actually very interesting because we had a whole bunch of different perspectives that showed up in those different discussions. Some people talking about what big data meant to them, some people talking about little data, just analyzing little bits and pieces of models here and there, using Dynamo, using database connectivity, using Excel, all kinds of stuff, Tableau, Power BI, and it was very interesting. And I wanted to share a little bit of some of that discussion with you guys. Primarily because, I think it's very misunderstood throughout the industry what big data means, and we just use it flippantly, like, oh yeah, we're going to do some big data, or let's go grab some big information and use this in our projects. And I think that it's kind of like a pet peeve. Maybe today is more like a what grinds my gears kind of session. I don't know, but I want to talk about what big data really means to the industry. So I'm going to kind of jump over to the internet here, and we're going to take a look at what Wikipedia has to say about this. So you can see here on my screen in Wikipedia, the term has been used since the 1990s. The individual here, John Massey, is kind of the guy who came up with this. And yes, I know, guys, I'm using Wikipedia as a source of truth. It's generally close-ish, right? So we're going to take a look at some other information in a minute here, but just some general quick information. You guys can do a quick search on BIM, big data and see this for yourselves as well. The real key here is that there's a lot of information, a ton of information. So when we're talking big data, down here there's a whole bunch of V's that get brought into the discussion. There's volume, there's velocity, there's variety, there's veracity of data. It's all kinds of you're getting bombarded with information. In the world of architecture and engineering and construction, within our individual companies, I don't think we really practice anything that comes close to big data. Most of us are really closed. We work within our own industry or with our own partner companies. We don't really share the information around all that much. So we're working with a fairly finite data set. That means it really cannot be big data, not by definition of this. Now there are other ways of using this information. If I recall down lower on this particular page, I should have looked this up ahead of time exactly where this was. Yeah, well, kind of ignore that. Let's go back over here to the SAS page, because this is another spot where they were kind of talking about the exact same thing. So all across the board, when you're looking at big data, this is what you see. Volume, velocity, variety. Those are the big three top V words that get used here. There's a lot of information that's being traded around. It's coming in very, very quickly, and it's very diverse. So let's talk about what we mean about some data that surrounds our models that we might use. Generally, you might be thinking about something like schedules in Revit. That's one thing that would be considered like a bit of data, okay? You might consider tagging in your floor plans as a bit of data. And that's all information. And Revit's great. If we're talking about Revit specifically, it's a fantastic tool that really allows you to streamline the documentation of that data for our construction document sets. But let's talk about what be more relatable to big data. Let's talk about how long it takes you to complete a project of a certain type, of a certain square footage. Now you're talking a little bit bigger data. we're not talking about data that's necessarily directly in the model. Well, it sometimes comes down to that. We're kind of talking more about things that you can use for business analytics, things that you can analyze how your business processes and workflows are working. And as we become more advanced in the world of building information modeling, I see more and more of you asking questions about figuring that kind of information out. How do I understand how long it's taking my Revit models to open and the performance aspects that you know, the things that I can improve upon to kind of fix that, to make that more expedient, to make people not wait quite as long all the time for the Revit model to open or to sync and say sync to central or whatever, right? What are the factors that contribute to Revit model file size? Is it just loaded number of families? Is it how many views I have in the project? How many instances of such and such a type of object, like detail lines or things like that? What happens when somebody explodes a DWG in a project file, and how can I detect if that's happened? That's stuff that goes beyond just normal everyday Revit workflows, and while it directly affects the Revit workflows or is affected by our Revit workflows, it's stuff that we really can't easily predict right now or analyze in any real meaningful way. Now, this is where it ties back to the Build conference, okay? When we were sitting there in Data Day, there was a couple people who were talking about, in my company, this thing means models are bad. And then the next person says, well, in my company, these are the things that we pay attention to determine if model is bad or good or performing well or is of poor health or whatever the terminology is you want to use. And in a lot of cases, it came down to number of views in the model. It came down to number of loaded families versus number of used families. It came down to number of imports or links, and not just the number of the links, but number of instances of links, right? So these are all different metrics that these individual companies discovered meant something to them. And then there was other information that they also wanted to talk about. How does this, this model, maybe it's running good, but how does it compare to my actual company standard? That's other information. Now, many of you are probably sitting there going, well, these are questions we've been asking for a while, Shawn, whatever. Yeah, we have been. Many of us have been asking these questions for a long time, and there's not really been a great way for us to go through and consistently predict or determine some of these factors and compare them to other projects of a similar type, more than just our subjective opinions about these things. I can give you my opinion and what I've seen work, but being human, there are things that I'm going to forget. There are data metrics where my mind doesn't draw the parallel to what actually was causing the problem. Back to big data. The whole purpose of big data is to try to find things like these trends, to really dig in and determine, what are the actual factors? I can think I know what a factor is. If somebody explodes a DWG in my project, is that going to truly be detrimental to the project's performance? Maybe. How badly is it going to degrade it? Can I predict based on a DWG size, the file size, how much it's going to affect my Revit model ahead of time? Or can I predict if somebody did do that, what views that might have been in, and can I go back and back check it and find a good way of repairing it without spending a lot of my time? So the whole point of big data is I don't want to invest an 8-hour day in digging through somebody's model to try to help to fix it. I really don't want to sit there and play firefighter all the time. And that's what many of you in the BIM management world are going to be doing. You're constantly playing firefighter. Somebody has a problem and they come screaming over to your desk and like, hey, Joe, I've got this problem and I have a submittal that has to be printed in 5 minutes and I need you to fix this yesterday. And you're in the middle of something, so of course you have to drop what you're doing and you got to go fix this model, but you can't just fix it. You got to spend a couple hours of your time investigating it. You didn't know it was going to happen, and that's a problem. So with big data, you can see me here, I'm using air quotes, big data, with a bunch of data, we'll call it that. We'll say with a bunch of information that you can gather, you can go after these models, and instead of being a firefighter and putting out fires once they've started, you can be a bit more predictive in certain cases depending on how you use this data. And that's just one example of how you could use this. You could use this to compare models throughout its life cycle to the original template from which it was sourced. You could use this big data, this abundance of data that we have in a single Revit model to do things like estimations or ordering or potentially facility maintenance, right? Like facility maintenance is just a database of information about a project. Now it's once the project's been constructed and you're using it, but that's some information. Now, let's again go back to this concept of big data. So let's say in your company, let's use a mid-sized architectural firm, 50 architects and designers and Revit users, let's say. Across your company, you don't have just one project. So, you know, if you're a two-person firm, you have one or maybe two projects that you work on, and if there's a problem coming up, you have your thumb on the pulse of, well, your fingers on your thumb on a pulse is a bad idea because your thumb is a pulse. And I digress. You get your fingers on the pulse of those projects because you're a small company. But if you're a 50-person company, there might be a number of projects that are running simultaneously, 10, 15 projects at the same time, depending on what, you know, how big your projects are. Sometimes 20 projects, you know, 3 people a project is just fine. In that case, you as a BIM manager, you're unlikely going to have your fingers on the pulse of every single project. As it progresses, you're only going to really be aware when people start complaining about things. And at that point, it's kind of too late. Once a project is completed, if you wanted to go back and just kind of back check it and go see how does this model actually compare to the rest of my stuff, you don't have a good way right now natively without hand doing it. I know I had a lot of companies who used to call me up mid-project and say, Shawn, can you check this project for me? Can you do like a health check before there was any Autodesk health check type tools that were out there? And you guys might be doing this as well. That's easily an 8-hour process of just sitting there and going through a model and writing down all the metrics, opening up different interfaces and narrating behind, you know, what you think this model's health is based on what you're seeing and observing. And, you know, sometimes you have to compare that to a template. Sometimes you have to just compare it to general experience. But the problem is, again, still, it's very subjective in a lot of cases when it's just a human doing this check. You can go, hey, I see you have a lot of these things, whatever they are. You got a lot of warnings. What does a lot of warnings mean? Are they even detrimental? I don't know, right? Well, I mean, I do know in some cases, and some of you do as well. But the goal here is, again, to make this prescriptive, to really figure out, what does that mean? What does a lot of warnings mean? What does a lot of imports mean? What is it, you know, a lot of unused families? Is it really a big problem on my project? Unplaced views, you know, what? So how do you make this more prescriptive? Let's jump back over and talk. I'm going to go back to my desktop here. We're going to talk about another web page here. So Autodesk has a tool that can actually let you do a little bit with this information. In this case, it's called Revit Database Link, RDB Link. Now, some of you have maybe heard of this. Some of you maybe have dabbled in it. Personal opinion from my side, this is not my favorite tool to play with. It's not super intuitive. It's not super easy to you know, modify the settings and whatnot, and to get it to do exactly what I want. And really, I'm limited to what the tool itself tells me I can get. But what this will do for you, if you decide you want to start playing with it, and there's other ways of working with the database access as well, you can dump the information from a Revit model out to an Access or Excel file, basically. And you can look at it. And in some cases, you can manipulate some of the information and import it back in, sort of. It's not super streamlined. It kind of breaks a lot. Kind of doesn't really do what you want. But it's an entry way of getting this to kind of do some interesting things. But what you're getting with this is a single capture of a finite amount of information at a specific point in time. And it's while going to an Access database, the information within a single Revit model is sort of related to each other. That's great, but you're not really getting a true sense of big data because it's one model at one point in time and you can see some information and maybe use this to write a narrative about the health of the model at that point. It doesn't tell you how you got there, but it does tell you the health at that point. And you have to do a lot of your own work here because it just goes to Access. You got to write your own reports and kind of, you know, stuff like that and figure out the database and all that fun jazz. Oh, let's look at a different tool. Since we're talking about health checking, and this was a huge thing that was discussed at the Data Day at the Revit Technology Conference family of events, the BILT conference. So if I go over here, Revit Model Checker, this is another tool that Autodesk has released. It's an add-in specific for Revit, and this helps you go in there and check your model based on different standards. Now this is pretty cool because this one here you can go in and you can set up different standards. In fact, Autodesk gives you some from different locations like the Ohio State University and State of Tennessee OSA model checks, and so they've got some pre-configured standards here that you can play with. That's pretty cool. You can even write your own standards here in this tool and tell it to check against some things. But again, it only checks certain things. It checks the data and gives you a report back saying, yes, you did this thing that you were expecting, or no, you did not. It doesn't really tell you the health of the model. It just says, you've got exterior wall types that don't match the type naming configuration. Okay, well, thank you. That's good. I mean, that's good information. That saves me hand checking this and spending a bunch of my time. But again, this isn't really talking performance of the model. It's just talking one small piece of the data. So while it's cool, it doesn't go the distance. So there's other ways you can work with this. There's information. If you want to know more about the performance of a model, like how long does it take to open it in the first place? How long does it take to sync to central maybe? How long does it take to regenerate a specific view in the model? And how has that changed over a period of time? Well, now we got to dig a lot deeper than most of these other pre-built tools work. Like the Revit database link doesn't talk at all about model performance. The model checker doesn't really talk, as far as I know, at all about performance because it doesn't care about how long it takes to open or save the model. It cares what's in the model. And again, that's a bit of important data. What else though? So let's say we wanted to, you wanted to build your own type of system that tracks this information. It's doable. A lot of the people at the data day were building their own solutions. I spoke with people from AECOM. I spoke with people from Perkins and Will. I spoke with people from, what was it, HKS. All these large companies, they're trying to figure all this information out because it's becoming more and more relevant. And you guys now might be tuning yourselves out. Well, I'm a 10-person firm. I can't do this. Well, you can. Just hear me out. We'll get there in a minute here. But there's a file type when you're dealing with Revit Central models that is called a slog, a .slog. I'm not sure what the S stands for, but obviously it's some kind of a log file, a save log or an activity log of some sort. So down here it's the work sharing log file. You can find this file. In fact, if you go to how to read Revit work sharing slog file, if you were to search for this, obviously you'd go to the the Autodesk knowledge base network, and you'd be able to read about how to interpret this file. There's some really interesting things you can discover on your own about a model, and this is stored where the central file is. You can see who's accessing it, well, kind of who's accessing it and what computer they're on. You can see exactly the journal file right here. If you notice this tells you the exact journal file that's being used on that particular user's local computer. And so you can actually look at the individual sessions. And this is actually why a lot of people will use this to kind of figure out what else is going on in the model. You can see the actual host machine that was used to access this thing. You can see the Revit username up here. This isn't the computer username, but the Revit username, which typically is either the Autodesk ID if they're signed in, or probably their Windows username by default, unless they change it somehow. You can see what Revit build they're on. That might be meaningful information. And there's other types of stuff you can find out as well. Again, there's the whole detail bit about the build of this and which users are actually accessing this file. You can see if they're reading or writing information, what's happening with the log while they're doing that. You can see how long it takes to sync to central. Now, this is an important piece of information. How long does it take to sync? You can take that data and figure out if the model is still performing well or if it's starting to slow down and lag. That might be interesting to you. There's a lot of stuff here. Whether or not there's links in the model, some stuff like that. I don't know, other stuff, type of stuff that's in here. That's about it. That's the slog file doesn't give you a lot, but what it does give you is meaningful. Okay. What else? How about the journal file that actually the slog references? And you're going to see multiple journal files referenced as the slog file updates. So if there's 3 or 4 people accessing throughout the day, user A will have a journal file that might be .0001, right? The first time they've ever used Revit. If Somebody else accesses it. They might be, you know, .0406 like this one is. That somebody else might be a different one, but it's all stored on their local user computers. So then you can go up and you can actually investigate or harvest those journal files. And there's some tools out in the market right now that let you do some journal file parsing and understand what's going on inside the journal file, what the user was actually doing. And I mean, take a look at some of those tools if you have an interest in this. So again, you can start to understand what's actually happening during the Revit session. Is somebody exploding a drawing? How are they drawing? How are they working? So there's some fun things you can do. You go, well, how do I do this? Well, you have to be able to parse through and programmatically sort of read those slog files. So you might have to get a little bit of programming under your belt if you want to do this yourself. And then you also have to be able to take these journal files and read them. Again, probably programmatically, because reading them by hand kind of isn't the most fun task in the world. So, all right. We got that out of the way. We can talk about some of the information. You can get some of the data about the model. Going back to big data, this still isn't big data. This is data, small data right now. We're talking a project so far, only a single project, and how this can actually affect what's going on. All right. Also, by the way, I have a little other message up here, a little tab up here. I was trying to figure out if I could see slog files dealing with Revit server and C4R projects, because I was doing my own research on this for my own nefarious purposes. You can find slogs on Revit server, though C4R stores information in a very different way, and so you can't really find slogs for C4R. You have to track your information in a different fashion. So that might be a hurdle for a few of you. And that's fine. You know, again, the whole point of getting this lot of data is figuring out what this means for you. All right. Recently-ish on the show, maybe about a year ago, I had Ryan Cameron on. Ryan Cameron works for, is it HDR, I believe? Oh man, I can't remember. I think Ryan works for HDR. If I'm wrong, please correct me on that, Ryan. I'm sorry. Ryan Cameron has a YouTube channel up. He's got a lot of interesting information, and a couple of the things we talked on the show was presenting back data to yourself in a meaningful way. So if you collect a lot of this data, it is cool. It's good information. The problem is then you have to interpret this data and figure out what it means. And this is where we get more towards that business analytics thing. Now, Ryan was primarily using this in this data-driven analysis down here, and his really cool little idea there for Alexa for data-driven day in Toronto for, I think this was 2 or 3 years ago that he did this. It was a year ago, 2 or 3. 1 year ago, he did this at Data Day in Toronto, and he talked about, you know, how he's using this, and he hooked up Alexa. It was a pretty cute, pretty cool presentation on that. So you guys might want to go take a look at what he's doing. It's kind of fun. But he isn't using this for analyzing the performance of a model. He's using it to figure out things like balance of occupiable space from the point of view of an architect. Now that's cool too, because that's more data that you can use. It goes well beyond just performance, but also about a specific individual model. Now, if you wanted to extrapolate that out, if you wanted to see how this model progressed over time and see how the design has changed for usable versus occupiable or rentable spaces and things like that, that could be fun. But you have to have a way of tracking this. What he's doing is live pulling data from the model to an Excel spreadsheet and then or to some file type, and then using, I believe he's using Microsoft's Power BI in most cases to go through the exercise of organizing that data in a meaningful way. That's fantastic, right? Cool stuff. But if we're talking about big data, this, and even I think in our discussion when I was talking with Ryan, we didn't talk big data. We talked small data, very generalized data, just information about a project at a point in time. So there's other things that you can do with this. There's a lot more that you can do. Let me get my cursor on the right page here so I can switch my scene here. There we go. There's a lot more that you can actually do with all of this information, but you have to store it somehow. This is the big key. It has to be stored in a meaningful way. So now you got to talk about databases. You got to talk about collecting all of this info. After you collect all this info, you have to dump it someplace that's meaningful. And you know, I know CTC Software, they have a tool set, and I'll take a look at this in a minute so you guys can see a package solution that you can investigate how this might work for you for health checking and performance tracking and standards checking and all kinds of stuff like that. But you have to have a database because you got to store now larger amounts of information. If I wanted to take the one small example of occupiable space in a building, the area planning stuff, and I want to track that over the life cycle of my design. Well, I got to have something to store that information in. I could use Excel, but a lot of that information is bigger than just Excel. If I wanted to know how it changed on just the 3rd floor, I have to track very granular information, how it worked from a specific zone or how a specific room has changed and morphed over time. You have to track all those individual pieces of data. And Excel really isn't very well suited for that. You know, if you're talking months of information. If you go bigger than that and you start tracking what is in my model from a health check perspective and how did that change over time and how does that compare to my template and how did it compare to my template last week versus this week, again, you have to have a database at play. Start investigating something like SQL Express or Full SQL Server, or there's a couple of other databases out there, MongoDB, or there's all kinds of different solutions, some that are entry level, some that are a bit more advanced, but store your information. There's all kinds of considerations around that. Do you want structured or unstructured types of databases? And you got to do your research on this. If you're going to start getting into this field of doing this tracking on your own and writing your own tools, you have to become aware of what the options are. This was all discussions that we had during Data Day. Again, a lot of the presenters went up and said, these are all types of topics we had to figure out on our own for what we needed. In one case, was it SOM, I think, was talking, and they were discussing, like, you know, when we went through this, we initially started here on this certain kind of concept and it didn't work for us. We had to go through this couple of other iterations and keep learning about databases, and now right now we're at this point and we're still improving. It's a non-stop thing when you're developing it yourself and internally. But again, SOM, you know, they might be listening to this and they might disagree with me. But you know, they've got bigger pockets, maybe not deep pockets, but bigger pockets, bigger pools of money and bigger talent pools than some of us in the smaller and mid-sized firms. And so, to be fair, a lot of you guys, you're going to be doing this after hours on your own if you really want to start digging in on this concept of big data or bigger data in your environment to track this. What's the end game look like, though? A lot of these companies were kind of coming to the same conclusions this last Data Day. I want to track the performance of my model. How fast does it open? How fast does it sync to central? How big is the file size? What computers are people using? What's the specs on those types of workstations? And then some major metrics that were important to them that were in the model. Things like number of warnings, number of views, views on sheets, unplaced rooms, unenclosed rooms, spaces. Are things zoned? Is there connectivity to MEP elements? How many loaded and unused families do I have? Like, there's all this stuff. How does that compare to my standards? And so many of them were settling on some variation of database where they're tracking this information. They have their own programmers in-house who are finding a way to get this, whether it be getting it through Dynamo on a manual click button process and parsing slog files, or whether they have some kind of a tool set that they've written that does it automatically. So again, let's go back to making this big data, bigger data concept available to all of you, to everybody who might be watching this. CTC software, Revit Express tools, CTC Express tools, has a tool set that's called BIM Data Suite. Now, you know, on this show, I try not to make this thing all commercial and all, you know, hey, buy this tool set because it's the best. That's not my goal. My goal is to make you aware of different things you can possibly do. This is a suite that I'm familiar with. I know a bit about it. I can tell you some of the stuff it can do. So if you've got questions, feel free to ask us about it. Ask me about it, and I can direct you, you know, how you can leverage this. If you want to go and find out more for yourself, there's ctcexpresstools.com here. And you can go through, there's a little video about what it can do and how it kind of works and some of the challenges you run through. But the intent of this whole suite of tools really is to have a packaged way for you to collect all that information. How long does it take to open? How long does it take to save? What's the file size? How many warnings? What are the warnings? That basic information. You can get that on the fly. You don't have to sit there and push a button all the time to parse a bunch of information and then forget and then lose the data. Because that's the big key. If there's something has to be clicked manually by a human on a regular basis to get this info, probably not going to happen. You're probably going to lose information and you're not going to get a full set of your data. So the whole purpose of this suite is to let you go through and capture that as seamlessly as possible. And there's other ways of digging deep into a model. This particular suite has two tools, one that captures performance data and one that captures model specific data. And you can go as deep as you want. That's one of the key factors of this is, a lot of the tools that you see out in the industry, even the Autodesk based tool here, that model health check tool over here, you're limited by what it thinks you want to get. If you want more, you have to wait for Autodesk to write that for you. One of the other goals here in the data suite is to give you as much information as you want. There's this tool, Project Snapshot Exporter, lets you grab all of the data, store it in a database, and you can do it at whatever frequency you feel is meaningful. So if you're going to write your own solution, you need to think about this as two separate tools like that. You need to think about getting the activity that's going on in the model, what's the performance data, and then getting the deep dive of the health check or the BIM information portion, the I in the model. That's kind of the two major steps. But still, as architects, and engineers and designers, we're still not practicing big data, even with a tool like this. Because even if you were to, for your own company, gather every single project from every user on every Revit workstation and capture your models at whatever interval, twice a week, once a week, bi-weekly, whatever, and start snapshotting every single model in your office, it is certainly a lot of data. Let's be real, it's going to be a lot of information if you capture all of that, but it's still not really big data because you're one company, you have a set workflow on a certain project type. Big data would be if we were to go nationwide, across the US, worldwide, across the world, and everybody was collecting this information real time and giving it back to some central server, and then we're going back and asking a question saying, how are models performing all over the world? Now we can start drawing parallels. Big data is the concept of finding true relationships of information. When I'm dealing with a 400 meg model, for me, maybe it opens in 2 minutes. For somebody else, maybe it opens in 45 minutes. Now we got to start drawing the parallels because it's not file size that determines file speed. I've also seen files that were 40 some meg in file size and took 45 minutes to open. Why was that? It's a tiny file. File size is not the only factor. It is a factor, certainly, but it is certainly not the only factor. In big data, in the world of architecture, is where you get to start going through and figuring out those types of correlations. Now, selfishly, what I would like to see is a way in our industry where we can actually do this, where I can get the HOKs and SOMs and HDRs and all those different companies, those big companies, the Perkins and Wills, the AE, whomever, to start sharing this information to a true central database, and we can start getting a much better idea of what's going on. But not just them. I want the 1 and 2 person firms and the 10 and 15 person firms to share their information, because your workflows are very different. And you've got different content you're using and different needs and different types of projects. You're doing a single family high-end residential house or a tract housing or something like that. That's going to be different, very much so, than say a stadium project. And so I'd like to see a way for us to all collect this kind of information. I'd like to start a conversation about that and see what can be done. So those of you who watch BIM broadcast and in your firms, you're kind of having these discussions internally, I'd like to sit down with you and have a bigger discussion potentially on what can be done. What you might think about, some of you large firms and even the smaller firms, on sharing this information. Because there's a lot of stuff that has to come up with this. One is how can it be done? But even more importantly, because, well, we're architects and engineers and designers and we kind of are private about our data. Should we? Could we? Are you guys willing to share even? I mean, these are the types of topics that I'd like to discuss with you guys. Now, a venue at which we might have this discussion, perhaps, where I'd like to sit down with a number of you maybe and talk about this. I'm going to pull up this other website here. I should have had this up ahead of time, but see if I can pull this up here. Midwest University.com. I think that's right. Dang it, I got it wrong. Shoot. Midwest. I should have had this up. Midwest-University-U. Maybe it's what it is. I don't remember. There we go. Midwest-U. I should know this off the top of my head, but I didn't. Right now, we are, I'm a part of the planning committee on this project here, this event. We are accepting class proposals. I encourage all of you to submit classes to Midwest University. Cool thing, you get a free pass to go. You get to attend all the classes and have a great time with us. But secondly, if you're not going to submit a class, please attend. And if you're interested in having discussions about this, I'd love to sit down with you while we're there and have a discussion about what big data means to you and what you'd like to see for this whole concept of sharing and you know, combining of data, and what metrics you think should be tracked, and what comparisons and what parallels maybe you've discovered that can determine some of that model performance information. So, you know, the whole goal here at BIM Broadcast is to discuss and to share and to talk and to collaborate on information. I don't want this to necessarily be a proprietary discussion about, hey, you know, one firm's idea. Let's make this kind of a bit more global. So feel free to interact with us, talk with me, you know, send me an email, whatever. You can see we've got Twitter up there. We've had some website information pop across. Of course, we've got social at bimbroadcast.com. You can feel free to email us there. And we're always interested in hearing what it is your thoughts are on these topics. Of course, you can also comment on the YouTube video. Obviously, this is, you know, streamed live right now, but those of you watching this in the future, comment back in the video. We watch that very closely, and we do care what your opinions are about topics like this, for one, and for two, big data. I want to know. I want to have this discussion maybe a couple more times with a few of you and kind of talk individually, one-on-one on BIM Broadcast. All right. That's all we've got for today. I really do appreciate the time you guys give to watching the show. If you haven't done so already, down at the bottom of the screen, right underneath the YouTube video there, bottom right corner, click the subscribe button. If you also want to be notified exactly when we're going live, when we do go live, because it happens, you know, we're going to try to make sure we're keeping this on a steady schedule. Hit the little bell there, and you'll be notified then when we go live and when there's new videos in case you miss it. With that, I thank you all for your time today. Hope you have a fantastic day, and keep the conversation open. Let me know what you guys think, and we'll talk with you in the future. Catch you later.